Chapter 11, Supply Chain Management. Outline: the supply chain's strategic importance. Sourcing issues, make or buy versus outsourcing. 6 sourcing strategies. Supply chain risk. Managing the integrated supply chain. Building the supply base. Logistics management. Distribution management. Ethics and sustainable supply chain management. Measuring supply chain performance. Learning objectives. When you complete this chapter, you should be able to explain the strategic importance of the supply chain, identify 6 sourcing strategies, explain issues and opportunities in the supply chain, describe the steps in supplier selection, explain major issues in logistics management, compute % of assets committed to inventory and inventory turnover. The objective of supply chain management is to coordinate activities within the supply chain to maximize the supply chain's competitive advantage and benefits to the ultimate consumer. The supply chain's strategic importance. The coordination of all supply chain activities, starting with raw materials and ending with a satisfied customer. This includes suppliers, manufacturers or service providers, distributors, wholesalers, retailers, and final customer. Most firms spend a huge portion of their sales dollars on purchases. Because an increasing percentage of an organization's costs are determined by purchasing, relationships with suppliers are increasingly integrated and long-term. Combined efforts that improve innovation, speed design, and reduce costs are common. Such efforts, when part of a corporate-wide strategy, can dramatically improve all partners' competitiveness. This integrated focus places added emphasis on managing supplier relationships. As Table 11.1 indicates, a huge part of a firm's revenue is typically spent on purchases, so supply chains are a good place to look for savings. Howley Furniture Incorporated spends 60% of its sales dollars in the supply chain and has a current gross profit of $10,000. Howe wishes to increase gross profit by $5,000, 50%. He would like to compare 2 strategies, reducing material costs versus increasing sales. Solution: the current material costs and production costs are 60% and 20%, respectively, of sales dollars, with fixed cost at a constant $10,000. Analysis indicates that an improvement in the supply chain that would reduce material costs by 8.3%, which is $5,000 divided by $60,000, would produce a 50% net profit gain for Howe, whereas a much larger 25% increase in sales, $25,000 divided by $100,000, would be required to produce the same result. A supply chain for beer. The supply chain includes all the interactions among suppliers, manufacturers, distributors, and customers. A well-functioning supply chain has information flowing between all partners. The chain includes transportation, scheduling information, cash and credit transfers, as well as ideas, designs, and material transfers. Even can and bottle manufacturers have their own tiers of suppliers providing components such as lids, labels, packing containers, etc. Costs are approximate and include substantial taxes. As suggested in Table 11.2, a firm needs to determine strategically how to design the supply chain. However, prior to embarking on supply chain design, operations managers must first consider the make or buy and outsourcing decisions. As we saw in Chapter 5, choosing products and services that can be advantageously obtained externally as opposed to produced internally is known as the make or buy decision. Outsourcing, on the other hand, transfers some of what are traditional internal activities and resources of a firm to outside vendors, making it slightly different from the traditional make or buy decision. Outsourcing, discussed in Chapter 2, is part of the continuing trend toward using the efficiency that comes with specialization. The vendor performing the outsourced service is an expert in that particular specialty. This leaves the outsourcing firm to focus on its key success factors and its core competencies. There are 6 sourcing strategies. With the many suppliers strategy, a supplier responds to the demands and specifications of a request for quotation, with the order usually going to the low bidder. This is a common strategy when products are commodities. This strategy plays one supplier against another and places the burden of meeting the buyer's demands on the supplier. Suppliers aggressively compete with one another. This approach holds the supplier responsible for maintaining the necessary technology, expertise, and forecasting abilities, as well as cost, quality, and delivery competencies. Long-term partnering relationships are not the goal. A strategy of few suppliers implies that rather than looking for short-term attributes, such as low cost, a buyer is better off forming a long-term relationship with a few dedicated suppliers. Long-term suppliers are more likely to understand the broad objectives of the procuring firm and the end customer. Using few suppliers can create value by allowing suppliers to have economies of scale and a learning curve that yields both lower transaction costs and lower production costs. This strategy also encourages those suppliers to provide design innovations and technological expertise. As with all other strategies, a downside exists. With few suppliers, the cost of changing partners is huge, so both buyer and supplier run the risk of becoming captives of the other. The purchaser must also be concerned about trade secrets and suppliers that make other alliances or venture out on their own. As shown in Figure 11.2, vertical integration can take the form of forward or backward integration. In vertical integration, we mean developing the ability to produce goods or services previously purchased or to actually buy a supplier or a distributor. Backward integration suggests a firm purchase its suppliers. Vertical integration can offer a strategic opportunity for the operations manager. For firms with the capital, managerial talent, and required demand, vertical integration may provide substantial opportunities for cost reduction, higher quality, timely delivery, and inventory reduction. Vertical integration appears to work best when the organization has a large market share and the management talent to operate an acquired vendor successfully. Backward integration may be particularly dangerous for firms in industries undergoing technological change if management cannot keep abreast of those changes or invest the financial resources necessary for the next wave of technology. Because vertical integration is so dangerous, firms may opt for some form of formal collaboration. As we noted in Chapter 5, firms may engage in collaboration to enhance their new product prowess or technological skills. But firms also engage in collaboration to secure supply or reduce costs. The trick is to cooperate without diluting the brand or conceding a competitive advantage. Keiretsu networks. Many large Japanese manufacturers have found another strategy. It is part collaboration, part purchasing from few suppliers, and part vertical integration. These manufacturers are often financial supporters of suppliers through ownership or loans. The supplier becomes part of a company coalition known as a keiretsu. Members of the keiretsu are assured long-term relationships and are therefore expected to collaborate as partners, providing technical expertise and stable quality production to the manufacturer. Members of the keiretsu can also have second and even third-tier suppliers as part of the coalition. Virtual companies rely on a variety of good, stable supplier relationships to provide services on demand. Suppliers may provide a variety of services that include doing the payroll, hiring personnel, designing products, providing consulting services, manufacturing components, conducting tests, or distributing products. The relationships may be short or long-term and may include true partners, collaborators, or simply able suppliers and subcontractors. Whatever the formal relationship, the result can be exceptionally lean performance. The advantages of virtual companies include specialized management expertise, low capital investment, flexibility, and speed. The result is efficiency. We are not done yet. Part 2 is waiting for you. In this age of increasing specialization, low communication cost, and fast transportation, companies are making less and buying more. This means more reliance on supply chains and more risk. Managing integrated supply chains is a strategic challenge. Having fewer suppliers makes the supplier and customer more dependent on each other, increasing risk for both. This risk is compounded by globalization and logistical complexity. In any supply chain, vendor reliability and quality may be challenging. But the new model of a tight, fast, low inventory supply chain, operating across political and cultural boundaries, adds a new dimension to risk. As organizations go global, shipping time, lead time, may increase, logistics may be less reliable, and tariffs and quotas may block companies from doing business. In addition, international supply chains complicate information flows and increase political or currency risks. Supply chain risks arise in numerous ways, and you cannot outsource risk. Table 11.3 identifies major categories of risks and tactics to help manage them. The development of a successful strategic plan for supply chain management requires careful research, a thorough assessment of the risks involved, and innovative planning. Companies need to focus not only on reducing potential disruptions but also on how to prepare for responses to inevitable negative events. Flexible, secure supply chains and sufficient insurance against a variety of disruptions are a start. They may also choose to diversify their supplier base by using multiple sources for critical components. McDonald's uses multiple suppliers tactic to mitigate the risk of delivery failure. Darden Restaurants carefully selects the suppliers, uses training, certification, and monitoring to reduce the risk of quality failure. Walmart, in order to counter the risk of logistics delays or damage, uses multiple or redundant transportation modes and warehouses, secure packaging, effective contracts with penalties. Toyota, in contrast, employs the tactic of careful selection, monitoring, and effective contracts with penalties to mitigate the distribution risk. To handle the risk of information loss or distortion, Boeing utilizes redundant databases, secure IT systems, training of supply chain partners on the proper interpretations and uses of information. Hard Rock Cafe deals with political risk by purchasing political risk insurance and embracing cross-country diversification, franchising and licensing. Honda and Nissan mitigate the economic risk by hedging to combat exchange rate risk, purchasing contracts that address price fluctuations. Toyota embraces the tactics of buying insurance, alternate sourcing and cross-country diversification to face the risk of natural disasters. The Domestic Port Radiation Initiative taken by the U.S. government is an example of theft, vandalism, and terrorism risk mitigation. There is probably no society more open than the U.S. This includes its borders and ports, but they are swamped. Millions of containers enter U.S. ports each year, along with thousands of planes, cars, and trucks each day. Even under the best of conditions, some 5% of the container movements are misrouted, stolen, damaged, or excessively delayed. Since the September 11, 2001, terrorist attacks, supply chains have become more complex. However, technological innovations in the supply chain are improving both security and inventory management, making logistics more reliable. Technology is now capable of knowing truck and container location, content, and condition. New devices can even detect broken container seals. Motion detectors can also be installed inside containers. Other sensors record interior data including temperature, shock, radioactivity, and whether a container is moving. Tracking lost containers, identifying delays, or just reminding individuals in the supply chain that a shipment is on its way will help expedite shipments. As managers move toward integration of the supply chain, substantial efficiencies are possible. However, it can lead to actions that may not optimize the entire chain. On the other hand, the supply chain is full of opportunities to reduce waste and enhance value. We now look at some of the significant issues and opportunities. 3 issues complicate development of an efficient, integrated supply chain: local optimization, incentives, and large lots. First, local optimization. Members of the chain are inclined to focus on maximizing local profit or minimizing immediate cost based on their limited knowledge. Slight upturns in demand are overcompensated for because no one wants to be caught short. Similarly, slight downturns are overcompensated for because no one wants to be caught holding excess inventory. So fluctuations are magnified. Second, incentives. Sales incentives, quantity discounts, quotas, and promotions. Incentives push merchandise into the chain for sales that have not occurred. This generates fluctuations that are ultimately expensive to all members of the chain. Lastly, large lots. There is often a bias toward large lots because large lots tend to reduce unit costs. A logistics manager wants to ship large lots, preferably in full trucks, and a production manager wants long production runs. Both actions drive down unit shipping and production costs, but they increase holding costs and fail to reflect actual sales. These 3 common occurrences: local optimization, incentives, and large lots, contribute to distortions of information about what is really occurring in the supply chain. A well-running supply system needs to be based on accurate information about how many products are truly being pulled through the chain. The inaccurate information is unintentional, but it results in distortions and fluctuations, causing what is known as the bullwhip effect. Accurate pull data are generated by sharing 1. Point of sales (POS) information so that each member of the chain can schedule effectively, and 2. Computer-assisted ordering (CAO). This implies using POS systems that collect sales data and then adjusting that data for market factors, inventory on hand, and outstanding orders. Then a net order is sent directly to the supplier, who is responsible for maintaining the finished goods inventory. Lot sizes are reduced through aggressive management. This may include 1. Developing economical shipments of less than truckload lots, 2. Providing discounts based on total annual volume rather than size of individual shipments, and 3. Reducing the cost of ordering through techniques such as standing orders and various forms of electronic purchasing. Single-stage control of replenishment means designating a member in the chain as responsible for monitoring and managing inventory in the supply chain based on the pull from the end user. This approach removes distorted information and multiple forecasts that create the bullwhip effect. Vendor-managed inventory (VMI) means the use of a local supplier, usually a distributor, to maintain inventory for the manufacturer or retailer. The supplier delivers directly to the purchasers using department rather than to a receiving dock or stockroom. If the supplier can maintain the stock of inventory for a variety of customers who use the same product or whose differences are very minor, say, at the packaging stage, then there should be a net savings. These systems work without the immediate direction of the purchaser. As with single-stage control and vendor-managed inventory, collaborative planning, forecasting, and replenishment, CPFR, is another effort to manage inventory in the supply chain. With CPFR, members of the supply chain share planning, demand, forecasting, and inventory information. Partners in a CPFR effort begin with collaboration on product definition and a joint marketing plan. Promotion, advertising, forecasts, joint order commitments, and timing of shipments are all included in the plan in a concerted effort to drive down inventory and related costs. CPFR can help to significantly reduce the bullwhip effect. Blanket orders are unfilled orders with a vendor and are also called open orders or incomplete orders. A blanket order is a contract to purchase certain items from a vendor. It is not an authorization to ship anything. Shipment is made only on receipt of an agreed-on document, perhaps a shipping requisition or shipment release. The purchasing department should make special efforts to increase levels of standardization. That is, rather than obtaining a variety of similar components with labeling, coloring, packaging, or perhaps even slightly different engineering specifications, the purchasing agent should try to have those components standardized. Postponement withholds any modification or customization to the product, keeping it generic, as long as possible. The concept is to minimize internal variety while maximizing external variety. For instance, after analyzing the supply chain for its printers, Hewlett-Packard, HP, determined that if the printer's power supply was moved out of the printer itself and into a power cord, HP could ship the basic printer anywhere in the world. Electronic ordering and bank transfers are traditional approaches to speeding transactions and reducing paperwork. Transactions between firms often use electronic data interchange, EDI, which is a standardized data transmittal format for computerized communications between organizations. EDI also provides for the use of Advanced Shipping Notice, ASN, which notifies the purchaser that the vendor is ready to ship. Although some firms are still moving to EDI and ASN, the Internet's ease of use and lower cost is proving more popular. Drop shipping means the supplier will ship directly to the end consumer, rather than to the seller, saving both time and reshipping costs. Other cost-saving measures include the use of special packaging, labels, and optimal placement of labels and barcodes on containers. The final location down to the department and number of units in each shipping container can also be indicated. Substantial savings can be obtained through management techniques such as these. Some of these techniques can be of particular benefit to wholesalers and retailers by reducing shrinkage, lost, damaged, or stolen merchandise, and handling cost. Blockchain seems poised to play a significant role in logistics, where it could change how supply chains work. Blockchains allow participants to add blocks of information after each firm validates transactions as they progress along the production, shipping, and delivery phases of a supply chain. The blocks are time-stamped and added to the chain at each transaction. The process is simpler and more secure than the array of barcodes, scanners, paper forms, and individual databases that a company has historically used. For those goods and services a firm buys, suppliers, also known as vendors, must be selected and actively managed. We now examine supplier selection as a four-stage process: 1. Supplier evaluation, 2. Supplier development, 3. Negotiations, and 4. Contracting. The first stage of supplier selection, supplier evaluation, involves finding potential suppliers and determining the likelihood of their becoming good suppliers. If good suppliers are not selected, then all other supply chain efforts are wasted. Supplier certification. International quality certifications such as ISO 9000 and ISO 14000 are designed to provide an external verification that a firm follows sound quality management and environmental management standards. A certification process often involves 3 steps: 1. Qualification, 2. Education, and 3. The certification performance process. Once certified, the supplier may be awarded special treatment and priority, allowing the buying firm to reduce or eliminate incoming inspection of materials. Such an arrangement may facilitate JIT production for the buying firm. Most large companies use some sort of supplier certification program. The second stage of supplier selection is supplier development. Assuming that a firm wants to proceed with a particular supplier, how does it integrate this supplier into its system? The buyer makes sure the supplier has an appreciation of quality requirements, product specifications, schedules, and delivery, and procurement policies. Supplier development may include everything from training, to engineering and production help, to procedures for information transfer. Negotiation represents a significant element in a purchasing manager's job, and well-honed negotiation skills are highly valued. Here are 3 classic types of negotiation strategies. Cost-based price model. The cost-based price model requires that the supplier open its books to the purchaser. The contract price is then based on time and materials or on a fixed cost with an escalation clause to accommodate changes in the vendor's labor and materials cost. Market-based price model. In the market-based price model, price is based on a published, auction, or index price. Many commodities, agricultural products, paper, metal, etc., are priced this way. Competitive bidding. When suppliers are not willing to discuss costs or where near perfect markets do not exist, competitive bidding is often appropriate. Competitive bidding is the typical policy in many firms for the majority of their purchases. Supply chain partners often develop contracts to spell out terms of the relationship. Contracts are designed to share risks, share benefits, and create incentive structures to encourage supply chain members to adopt policies that are optimal for the entire chain. Companies with multiple facilities must determine which items to purchase centrally and which to allow local sites to purchase for themselves. Unmonitored decentralized purchasing can create havoc. Important cost, efficiency, and single voice benefits often accrue from a centralized purchasing function. Typical benefits include: leverage purchase volume for better pricing. Develop specialized staff expertise. Develop stronger supplier relationships. Maintain professional control over the purchasing process. Devote more resources to the supplier selection and negotiation process. Reduce the duplication of tasks. Promote standardization. E-procurement speeds purchasing, reduces costs, and integrates the supply chain. It reduces the traditional barrage of paperwork and, at the same time, provides purchasing personnel with an extensive database of supplier, delivery, and quality data. Online catalogs and exchanges. Purchase of standard items is often accomplished via online catalogs. Such catalogs support cost comparisons and incorporate voice and video clips, making the process efficient for both buyers and sellers. Online exchanges are typically industry-specific internet sites that bring buyers and sellers together. Online catalogs and exchanges can help move companies from a multitude of individual phone calls, faxes, and emails to a centralized system and drive billions of dollars of waste out of the supply chain. Online auctions. In addition to catalogs, some suppliers and buyers have established online auction sites. Operations managers find online auctions a fertile area for disposing of excess raw material and discontinued or excess inventory. Online auctions lower entry barriers, encourage sellers to join, and simultaneously increase the potential number of buyers. In a traditional auction, a seller offers a product or service and generates competition between bidders bidding the price up. In contrast, buyers often utilize online reverse auctions, or Dutch auctions. In reverse auctions, a buyer initiates the process by submitting a description of the desired product or service. Procurement activities may be combined with various shipping, warehousing, and inventory activities to form a logistics system. The purpose of logistics management is to obtain efficiency of operations through the integration of all material acquisition, movement, and storage activities. Many firms opt for outsourcing the logistics function, as logistics specialists can often bring expertise not available in-house. The potential for competitive advantage is found via both reduced costs and improved customer service. Trucking. The vast majority of manufactured goods moves by truck. The flexibility of shipping by truck is only one of its many advantages. Railroads are capable of carrying large loads. Containerization has made shipping of truck trailers on railroad flat cars a popular means of distribution. Air freight. For national and international movement of lightweight items, such as medical and emergency supplies, flowers, fruits, and electronic components, air freight offers speed and reliability. Waterways. The usual cargo on internal waterways is bulky, low-value cargo such as iron ore, grains, cement, coal, chemicals, limestone, and petroleum products. Water transportation is often preferred when cost is more important than speed. Pipelines are an important form of transporting crude oil, natural gas, and other petroleum and chemical products. Multimodal shipping combines shipping methods and is a common means of getting a product to its final destination, particularly for international shipments. The use of standardized containers facilitates easy transport from truck to rail to ship and back again, without having to unload products from the containers until the very end. Faster methods such as air freight tend to be much more expensive, while slower methods, such as waterways, provide a much cheaper shipping rate per unit. The size of shipments follows a similar pattern. The faster methods tend to involve smaller shipment sizes, while the slower methods involve very large shipment sizes. Warehouses may be extremely expensive to operate, but the alternatives, example either no storage at all or storage at local operating facilities, along with the related logistics issues, may be much more costly. The fundamental purpose of a warehouse is to store goods. However, some warehouses also provide other crucial functions. For example, a warehouse can serve as a consolidation point, gathering shipments from multiple sources to send outbound in one cheaper, fully loaded truck. Alternatively, a warehouse can provide a break bulk function by accepting a cheaper full truckload inbound shipment and then dividing it for distribution to individual sites. Further, similar to a major airport hub, a warehouse can serve simply as a cross-docking facility accepting shipments from a variety of sources and recombining them for distribution to a variety of destinations, often without actually storing any goods during the transition. Finally, a warehouse can serve as a point of postponement in the process, providing final customer-specific value-added processing to the product before final shipment. Channel assembly represents one way to implement postponement. Channel assembly sends individual components and modules, rather than finished products, to the distributor. The distributor then assembles, tests, and ships. Channel assembly treats distributors more as manufacturing partners than as distributors. Supply chain managers outsource logistics to meet three goals: 1. Drive down inventory investment. 2. lower delivery costs, and 3. Improve delivery reliability and speed. Specialized logistics firms support these goals by creatively coordinating the supplier's inventory system with the service capabilities of the delivery firm. To be continued. A check sheet is any kind of a form that is designed for recording data. In many cases, the recording is done so the patterns are easily seen while the data are being taken. See Figure 6.6a. Check sheets help analysts find the facts or patterns that may aid subsequent analysis. An example might be a drawing that shows a tally of the areas where defects are occurring or a check sheet showing the type of customer complaints. Scatter diagrams show the relationship between two measurements. An example is the positive relationship between length of a service call and the number of trips a repair person makes back to the truck for parts. Another example might be a plot of productivity and absenteeism, as shown in Figure 6.6b. If the two items are closely related, the data points will form a tight band. If a random pattern results, the items are unrelated. Another tool for identifying quality issues and inspection points is the cause and effect diagram, also known as an Ishikawa diagram or a fishbone chart. Figure 6.7 illustrates a chart. Note the shape resembling the bones of a fish. For a basketball quality control problem, missed free throws. Each bone represents a possible source of error. The operations manager starts with 4 categories: material, machinery/equipment, manpower, and method. These 4 Ms are the causes. They provide a good checklist for initial analysis. Individual causes associated with each category are tied in as separate bones along that branch, often through a brainstorming process. For example, the method branch in Figure 6.7 has problems caused by hand position, follow-through, aiming point, bent knees, and balance. When a fishbone chart is systematically developed, possible quality problems and inspection points are highlighted. Pareto charts are a method of organizing errors, problems, or defects to help focus on problem-solving efforts. They are based on the work of Vilfredo Pareto, a 19th-century economist. Joseph M. Uran popularized Pareto's work when he suggested that 80% of a firm's problems are a result of only 20% of the causes. The Hard Rock Hotel in Bali has just collected the data from 75 complaint calls to the general manager during the month of October. The manager wants to prepare an analysis of the complaints. The data provided are room service, 54, check-in delays, 12, hours the pool is open, 4, minibar prices, 3, and miscellaneous, 2. The diagram shown here indicates that of the 5 types of complaints identified, the vast majority were of one type: poor room service. Flowcharts graphically present a process or system using annotated boxes and interconnected lines. See Figure 6.6e. They are a simple but great tool for trying to make sense of a process or explain a process. The diagram here uses a flowchart to show the process of completing an MRI at a hospital. Histograms show the range of values of a measurement and the frequency with which each value occurs. See Figure 6.6f. They show the most frequently occurring readings as well as the variations in the measurements. Descriptive statistics, such as the average and standard deviation, may be calculated to describe the distribution. However, the data should always be plotted so the shape of the distribution can be seen. A visual presentation of the distribution may also provide insight into the cause of the variation. Control charts are graphic presentations of data over time that show upper and lower limits for the process we want to control. See Figure 6.6g. Control charts are constructed in such a way that new data can be quickly compared with past performance data. We take samples of the process output and plot the average of each of these samples on a chart that has the limits on it. The upper and lower limits in a control chart can be in units of temperature, pressure, weight, length, and so on. Statistical Process Control, SPC, monitors standards, makes measurements, and takes corrective action as a product or service is being produced. Samples of process outputs are examined. If they are within acceptable limits, the process is permitted to continue. If they fall outside certain specific ranges, the process is stopped and, typically, the assignable cause located and removed. Figure 6.8 shows the plot of sample averages in a control chart. When the samples fall within the upper and lower control limits and no discernible pattern is present, the process is said to be in control with only natural variation present. Otherwise, the process is out of control or out of adjustment. To make sure a system is producing as expected, control of the process is needed. The best processes have little variation from the standard expected. In fact, if variation were completely eliminated, there would be no need for inspection because there would be no defects. The operations manager's challenge is to build such systems. However, inspection must often be performed to ensure that processes are performing to standard. This inspection can involve measurement, tasting, touching, weighing, or testing of the product, sometimes even destroying it when doing so. Its goal is to detect a bad process immediately. Inspection does not correct deficiencies in the system or defects in the products, nor does it change a product or increase its value. Inspection only finds deficiencies and defects. Moreover, inspections are expensive and do not add value to the product. Inspection should be thought of as a vehicle for improving the system. Operations managers need to know critical points in the system: 1. When to inspect, and 2. Where to inspect. Deciding when and where to inspect depends on the type of process and the value added at each stage. Inspections can take place at any of the following points. 1. At your supplier's plant while the supplier is producing. 2. At your facility upon receipt of goods from your supplier. 3. Before costly or irreversible processes. 4. During the step-by-step production process. 5. When production or service is complete. 6. Before delivery to your customer. 7. At the point of customer contact. The 7 tools of TQM discussed in the previous section aid in this when and where to inspect decision. However, inspection is not a substitute for a robust product produced by well-trained employees in a good process. There is variability in the inspection process. In addition, inspectors are only human, they become bored, they become tired, and the inspection equipment itself has variability. Even with 100% inspection, inspectors cannot guarantee perfection. Therefore, good processes, employee empowerment, and source control are a better solution than trying to find defects by inspection. You cannot inspect quality into the product. The best inspection can be thought of as no inspection at all. This inspection is always done at the source. It is just doing the job properly with the operator ensuring that this is so. This may be called source inspection, or source control, and is consistent with the concept of employee empowerment, where individual employees self-check their own work. The idea is that each supplier, process, and employee treats the next step in the process as the customer, ensuring perfect product to the next customer. This inspection may be assisted by the use of checklists and controls such as a fail-safe device called a Pokayoke, a name borrowed from the Japanese. A Pokayoke is a foolproof device or technique that ensures production of good units every time. These special devices avoid errors and provide quick feedback of problems. A simple example of a Pokayoke device is the diesel gas pump nozzle that will not fit into the unleaded gas tank opening on your car. Checklists are a type of Pokayoke to help ensure consistency and completeness in carrying out a task. A basic example is a to-do list. This tool may take the form of pre-flight checklists used by airplane pilots, surgical safety checklists used by doctors, or software quality assurance lists used by programmers. In service-oriented organizations, inspection points can be assigned at a wide range of locations, as illustrated in Table 6.4. Again, the operations manager must decide where inspections are justified and may find the 7 tools of TQM useful when making these judgments. When inspections take place, quality characteristics may be measured as either attributes or variables. Attribute inspection classifies items as being either good or defective. It does not address the degree of failure. For example, the light bulb burns or it does not. Variable inspection measures such dimensions as weight, speed, size, or strength to see if an item falls within an acceptable range. If a piece of electrical wire is supposed to be 0.01 inch in diameter, a micrometer can be used to see if the product is close enough to pass inspection. Knowing whether attributes or variables are being inspected helps us decide which statistical quality control approach to take. The personal component of services is more difficult to measure than the quality of the tangible component. However, what is very different about the selection of services is the poor definition of the 1. Intangible differences between products and 2. The intangible expectations customers have of those products. The operations manager plays a significant role in addressing several major aspects of service quality. First, the tangible component of many services is important. How well the service is designed and produced does make a difference. Second, another aspect of service and service quality is the process. Such things as reliability and courtesy are part of the process. An operations manager can design processes that have these attributes and can ensure their quality through the TQM techniques discussed in this chapter. Third, the operations manager should realize that the customer's expectations are the standard against which the service is judged. Customers' perceptions of service quality result from a comparison of their before-service expectations with their actual service experience. In other words, service quality is judged on the basis of whether it meets expectations. Fourth, the manager must expect exceptions. There is a standard quality level at which the regular service is delivered, such as the bank teller's handling of a transaction. However, there are exceptions or problems initiated by the customer or by less than optimal operating conditions, example the computer crashed. This implies that the quality control system must recognize and have a set of alternative plans for less than optimal operating conditions. Like many service organizations, Alaska Airlines sets quality standards in areas such as courtesy, appearance, and time. Shown here are some of Alaska Airlines' 50 quality checkpoints, based on a timeline for each departure. Table 6.5 lists the determinants of service quality. 9 out of 10 of the determinants of service quality are related to the service process. Well-run companies have service recovery strategies. This means they train and empower frontline employees to immediately solve a problem. For instance, staff at Marriott hotels are drilled in the learn routine, listen, empathize, apologize, react, notify, with the final step ensuring that the complaint is fed back into the system.